Hello and welcome. In this lesson, we are going to learn on how to evaluate questions on longitudes and latitudes. Let's go straight to the questions. Question number 1. The position of 3 points A, B, and C these are the coordinates of these positions: 34 degrees north, 16 degrees west, 34 degrees north, 24 degrees east, and 26 degrees south and 16 degrees west respectively. So those are the 3 positions, A, B, and C. So let's go to the first question. A, find the distance in nautical miles between part 1, port A and B to the nearest nautical mile. Part 2, the question, ports A and C. Then part B of the question, a ship left port A on Monday at 13:30 hours and sailed to port B at 40 knots. Calculate, part 1, the local time at port B when the ship left port A. Then second part, which is the last one, the day and the time the ship arrived at port B. So those are the questions. Now let's go to the first part of the question. Let's create the space here. So the first part of the question, we're given these 3 positions and you're required to find the distance in nautical miles between port A and B to the nearest nautical miles. Now it would be good if we would sketch the diagram. We sketch the diagram of these positions so that we can identify whether these positions lie on the circle of latitude or on the great circle. So let's do that immediately. So we want to locate these places. So let's sketch 34 degrees. So this is sorry for that. Let's have it again. Have it. So that is how it is. So we want to put these 34 degrees. Then you can indicate so this is 34 degrees north, and then this meridian is 24 degrees east, 4 degrees east. The other one, this meridian, is 16 degrees west. Then this is the position. This is another position that you'll have in this zone. So looking at what we have, the position of A is 34 degrees north, 16 degrees west. So this is position A. Then B is 34 degrees north, 24 degrees east. So that is position B. And then C is 26 degrees south. So this latitude here is 26 degrees south. So, and then 24 degrees, this 34 degrees, okay, it's 26, this is west, so it is here. So C, the position of C is here. 26 degrees south, 16 degrees west. Now, having those positions like that, now we can go and answer the question. The first one is the distance. You're supposed to get the distance. So let me so we can go ahead and get now the distance between port A and B to the nearest nautical mile. So you can see this is the distance AB. So that is the arc. That is the distance AB. So that distance is located on the circle of latitude, or the small circle. It is distance along the small circle or the circle of latitudes. So we need to get the formula how we get the distance between the circle of latitude in nautical mile. And to do that, distance is given by, that distance will be obtained by, that is the circle of latitude, longitude difference times 60 times cosine of theta, where theta is the latitude angle. That is the latitude angle. So this is distance. Distance AB is distance along the circle of latitude. That is distance along the circle of latitude. So that is how we get that distance AB. Longitude difference times 60 times cosine of the latitude angle. Now, so let's go directly and solve that. So distance is given by the longitude difference is, you can see for A, 16 degrees west. For B, that this is 24 degrees, so east. So the longitude difference will be given by 16 degrees plus 24 degrees. This is the longitude difference multiplied by 60 times cosine of the latitude along which both of them lie is 34. It is 34. So this gives 40 multiplied by 60 multiplied by cosine of 34 degrees. So working out these, it gives 1990 nautical miles. So that is the solution for the first part. So that is how we get the distance between port A and B in nautical miles. So let's go to the second part of the question. Now the second part of the question, we're required to get the ports A and C. Ports A and C. So we need to get that distance, ports A and C. Now when you look at the distance, these arc, port A and C, that is the distance. Sorry for drawing this badly. So that is the distance. So to get that is distance along the meridian. So that is distance along. So that is distance along the meridian. So distance along the meridian. And to get the distance along the meridian, that one is given by the latitude difference in nautical mile. So that distance will be given by latitude difference times 60. That is how we get that, because you look at that distance, it is not distance along the small circle or the circle of latitude, it is distance along the meridian. And distance along the meridian is given in nautical miles, it's given by latitude difference times 60. So in this case, to get the length of that arc, so distance of arc AC be given by latitude difference, which is look at the latitude. So this one is on latitude 34 degrees north, and the other one, C, is on latitude 26 degrees south. So it will be 34 plus 26 degrees multiplied by 60. So this gives 60 multiplied by 60, and this will give 3600 nautical miles. So that is how we get the distance between ports A and C. So distance between ports A and C, once again, A and C is distance along the meridian. To obtain the distance along the meridian in nautical miles is given by latitude difference times 60, and the latitude difference is 34 and 26. That is the difference, the latitude difference in the two latitudes. One latitude is 34 degrees, the other one is 26. Now let's go to the other part of the question. Part B, a ship left port A on Monday at 13:30 hours and sailed to port B at 40 knots. Calculate 1, the local time at port B when the ship left port A. So that is the question. Now we need to get the local time at B when the ship left port A. Now we're dealing with the time difference between two meridians, A and B. So the first thing will be, when you look at A and B, ports A and B, you can see they lie on different longitudes or meridians. So there must be time difference between the two. So time difference, so we need to get time difference between A and B. So to get the time difference, we need to get the longitude difference between the two. One is 16 degrees west, that is A, and B is 24 degrees east. So longitude difference will be 24 degrees plus 16 degrees. So this gives 40 degrees. Now when you're getting the longitude difference, you can see A is to the west and then B is to the east. So to get the difference, you add, and that is 40. So that is the longitude difference. So 1 degree is has a difference of 4 minutes. So what about these 40 degrees? This will give 40 times 4 minutes, which will give 160 minutes. 160 minutes is equivalent to 2 hours and 40 minutes. It's 2 hours and 40 minutes. So that is basically the time difference between these two meridians, A and B. So we have begun by getting the longitude difference. A is 16 degrees to the west, B is 24 degrees to the east. So getting the longitude difference, you add the two, you get 40 degrees. And then when you get 40 degrees, if 1 degree has a difference, gives a difference of 4 minutes, what about 40 degrees? So between A and B, there's a difference of 2 hours and 40 minutes. So the next thing you're going to do, upon knowing that, the ship left port A on Monday, 13:30 hours, and sailed to port B at 40 knots. So the local time at B when the ship left port A. So the ship left port A at 13:30 hours. So what was the local time at that time at B? So what was the local time? So when you look at B, B is to the east, and east is always ahead of time. East is always ahead of time. Not that places to the east is ahead of time. Is ahead of time. And therefore, this time it will be ahead of time with 2 hours 40 minutes. So if this ship left port A at 13:30 hours. So at B, what was the time at B, the local time at B, if it left 13:30 hours? So when it is 13:30 hours at A, what was the time at B? So since B is to the east, so it will be ahead of time. And all you're going to do to get the local time, so local time at B will therefore be obtained by taking 13:30 and we add this difference, 2 hours and 40 minutes. And this gives 16:10 hours. Since B will be ahead of time, and that is why we are adding 2 hours 40 minutes. That is a longitude time difference between A and B. Or this can be 4:10 p.m. So that is the local time. We go to part 2 of the question. Now for part 2 of the question, the day and the time the ship arrived at port B. The day and the time the ship arrived at port B. At port B. The day and the time the ship arrived at port B. So we are now aware that the time the ship left port A, we need to get the distance. We got the distance. So distance between A and B. Distance AB in nautical mile. We obtained that as we started here. It was 1990 nautical miles. So 1990 nautical miles. The speed was 40 knots. So these two can give us the time taken by the ship from A to B. So time we obtained by distance. This is the distance over the speed. The distance is 1990 divided by 40 knots. So when you divide nautical miles and the speed in knots, you obtain the answer in hours. So the answer you obtain here will be in hours. And working out this is the same as 199 divided by 4. This gives 49 hours and 45 minutes. I repeat that. When you get that speed, when you divide nautical mile distance with the speed with knots, you obtain your answer in hours. So because this will give approximately 49 3/4 hours, which is equivalent to that. So that is the overall time taken by the ship from A to B. Now that we have obtained the local time at B, this so local time at B, that is we have obtained that in the previous part, 16:10. That is the local time at B when the ship left port A. So that is the local time you're going to use. So that is 16:10 hours. So taking the total time, you shall add now to get the time it arrived at B, the local time it arrived at B. We are going to use 16:10, then we add 49 hours and 45 minutes. So 49 hours, this is today is this is a Monday. So Monday 16:10 hours, then Tuesday 16:10 hours, then Wednesday 16:10 hours. So you notice that this is 48 hours. Those are 2 days. Those are 2 days, 48 hours. So from 49, we need to add now 16 the hours that are remaining, because the total hours are 49 hours and 45 minutes, we need to add 1 hour and 45. This is 1 hour and 45. This is what is remaining. So this gives 5571, and this will still be Wednesday. So here you have 1 hour 45 minutes. Now when you add these 48 hours plus 1 hour 45 minutes, you get a total of 49 hours and 45 minutes. So therefore the local time, we have answered the question, the day and the time the ship arrived at port B. So having obtained the time taken from A to B was 49 hours 45 minutes, and having known the local time at B when the ship left A was 1610. So from 1610 add 49 hours 45 minutes, you get 1755 hours. Or you can give it as 5:55 p.m. So that is how you're supposed to work out that question. Question number 2. A ship sails from port P 20 degrees north, 30 degrees east northwards to port A, which is 45 degrees north, 30 degrees east, then due west to port R, which is 45 degrees north, 15 degrees west. It then finally sails a further 5,000 kilometers due west of port R to port S. Take the radius of the earth to be 6370 kilometers and pi to be 3.142. Question part A, find the total distance covered by the ship to the nearest kilometer, that is 5 marks. The second question, calculate the average speed of the ship if the whole journey took 25 hours. Then part C, determine to the nearest degree the position of port S. So those are the 3 questions. So let's go directly to part 1. Or is supposed to find the total distance covered by the ship to the nearest kilometer. So the first thing to do is to sketch on the globe the positions of these points P, and these are R and A, to see whether they lie on the circle of latitude or whether they lie on the great circle. So let's sketch. So let's name these longitudes. So there is one that is 45 degrees north and 20 degrees. So this is 45 degrees north. Then this is 20 degrees north. Then this longitude here is 30 degrees east. Then this longitude here is 15 degrees west. So the position of A, P, point P, 20 north, 30 east, 20 north, 30 east. So this is P. Then A, point A is 45, 30, 45, 30. So it is here, is point A. And then R R is somewhere here. R is 45 north, 15 west. 45 north. So R is here. And then it moves due west to point S. So point S can be somewhere there. So those are the positions of these points. So now the first question is supposed to find the total distance covered by the ship to the nearest kilometer. So you can see the movement. This ship moved. This is the total distance now. So total distance will be given by, it moved from point P to A, then it moved from A to R, and then it moved R to S, then R to S. So these are the distances in which you need to get. Now let's go take each distance at a time. We start with the distance PA. So distance PA is this distance that is here. In the diagram you can see it. So in that distance, that is distance along the meridian. So this is distance along the meridian, and that is distance along the great circle. So to get that distance, this is the formula that we're going to use to get that arc, the length of that arc AP. We get it by distance along the great circle or along the meridian is obtained by taking theta over 360 2 pi r, where theta in this case will be the latitude difference, where theta is the latitude difference. So in this case, you can see P is on 20 degrees north and A is 45 degrees north. So the latitude difference therefore will be given by, since both of them are to the north, we get the difference by subtracting 45 degrees minus 20 degrees. This gives 25 degrees. So that is the distance. That is the difference, the longitude difference. Now from there, after identifying the longitude difference, let's go and get the distance. So the distance will be given by, that is distance PA. Do it here. Distance PA given by the latitude difference, which is the latitude difference, which is 25 degrees divided by 360 multiplied by 2 times pi, which is 3.142, times the radius of the earth, which is 6370. So work out this using a calculator. This one will be 2779.7972 kilometer. So that is distance PA. Now we need now to obtain distance AR. Distance AR, that is the next distance. Now from the diagram here, you can see distance AR is distance on the circle of latitude. So that is distance on circle of latitude, or the small circle. That is the distance along the small circle or circle of latitude. So to obtain that such distance, the formula that we use is this. So distance will be given by theta over 360 times 2 pi r cosine of alpha, where theta is the longitude difference, and then alpha is the latitude angle. So we need to identify now. Let's start by getting the longitude difference. So that distance AR, we have the positions here. The positions of A is 45 degrees north, 30 degrees east, and then R is 15 degrees. So to get the longitude difference, we shall use 30 degrees east and 15 degrees west. So since these two places, one is to the east and the other one is to the west, to get the longitude difference, we add the two. So longitude difference will be given by 30 degrees plus 15 degrees, which is 45 degrees. And the latitude angle, you can see that these are two positions, A and R, they lie on the same latitude, which is 45 degrees. So after identifying that now, we can get the distance. So distance AR, therefore, is given by theta is 45 degrees, everything divided by 360, multiply by 2 times pi, which is 3.142, times the radius of the earth, 6370, multiplied by the cosine of latitude angle, which is 45 degrees. So that is how we're supposed to work out that distance. So work out these using the calculator. And when you work out these using the calculator, you get this one as 38.104 kilometer. So that is the distance AR. Now the other distance that we need to get now is distance RS. Distance RS is given directly because in this statement we have here, we told that it then finally sails further 5,000 kilometers due west of port R to S. So R to S is 5,000 kilometers. R to S. So RS is equals to 5,000 kilometers. Now, having identified that, we can now give the total distance. So total distance will be obtained by distance, the first distance that we got, which was PA, was 79.7972 plus the second distance which you have obtained, which is 38.104 plus 5,000. So this one, when you add it and give it to the nearest kilometer, you get 11,318 kilometers. That is to the nearest kilometer. That is what you get. So that is simply how you're supposed to get the total distance, identifying whether the distances lie on the circle of latitude or the great circle. And then it's important to sketch. Now let's go to the second part of the question, which is calculating the average speed of the ship if the whole journey took 25 hours. So to get the average speed is given by total distance divided by total time taken. So in this case, the total distance traveled by this ship is 11,318 kilometers. Total time taken given here is 25 hours. And this gives, when you work out this using the calculator, you get 452.7 kilometers per hour. So that is the speed. We go to the next part. Determine to the nearest degree the position of port S. The position of port S. Now, to identify the position of port S, let's go to the diagram, the sketch of the positions of these places. You see where the position S is here. That is position S. So to obtain the position of S, and we give the position of S in latitude and longitude. That is how we give. So what we have for S, let the position of S, let the position of S be, already we know it is located on the latitude 45 degrees north. 45 degrees north. 45 degrees north. Then what we don't know is the longitude, so we can let that on to be X degrees, and that is to the west, as you can see from this sketch. So what will help us to get the position of that S is that distance, because already we know the distance SR or distance RS. So we know the distance RS is 5,000 kilometers. So this will be very important in helping us get the position, since to obtain this distance, that is distance along the circle of latitude, and this distance was obtained this way. So distance RS is obtained by theta over 360 2 pi r cosine of alpha, whereas theta in this case is the longitude difference, which is what we are looking for. That is what you're looking for, which will help us obtain the position. We cannot get that. Then alpha is the latitude angle, and the latitude here is 45 degrees. So we can input everything that we have in that formula and then calculate what we don't have. Now, distance RS is 5,000. It's given by theta, we don't know that, over 360 multiplied by 2 times pi times 6370 cosine of 45 degrees. So from these you can see that we'll be able to obtain what we don't have in this question, which is the longitude difference is what we'll get. So we can get rid of this denominator 360 by multiplying 360 both sides. So this will have 5,000 multiplied by 360. This end, this right hand side, when you multiply by 360 will disappear, so that you remain with 2 times 3.142 times 6370 cosine of 45 degrees. So, and there is theta here. So we have theta multiply by that. So this is what you'll have. So since we are looking for theta, therefore theta will be given by 5,000 multiplied by 360, everything divided by 2 times 3.142 times 6370 cosine of 45 degrees. So working out these using the calculator very well, this gives 63.59 63.59 degrees. Now remember that this is not the latitude angle, but this is the longitude difference, which will help us so much in identifying the actual position of S. Now look at these two. Let's go back to the diagram here. When you look at the position, this distance RS, look at the position of R and then look at the position of S. Both of them are to the west. So if they are both to the west, to obtain the longitude difference, we subtract the longitude angle. And S, since S is ahead of, this one is to the left of R, will be higher. It will be a bigger value. So therefore, when you're getting the longitude difference, we'll take the longitude of S, subtract the longitude of R, and that will give us this longitude difference that we have. I repeat that. Take the longitude of S, subtract the longitude angle of R, and that will give us the longitude difference. So this is what I mean. So the longitude of S, which is x degrees, so x degrees, so longitude difference given by the longitude of S, x degrees, minus the longitude of R, which is 15, that one we know, it is on 15 degrees west. That difference should give us 63.59 degrees. So therefore, x degrees will be 63.59 degrees plus 15. And when you work out these, you give 78.59 degrees. That is what you're supposed to get. And therefore, the position of S will now be given as the latitude, which is 45 degrees north, and then our X, which is 78 degrees, is 78.59 degrees west. So that is the actual position of S, and that is how we're supposed to solve that.